Hello everyone, I am Nisha Patil and I am here to deliver a lecture for lecture series on Indian knowledge systems. This is for the Diamond Jubilee Year celebration of the Sanskrit Department, University of Mumbai. I congratulate the department and wish all the best for the further achievements. I thank Dr. Shakuntala Gowde, the head of the department, my teachers Dr. Mahulikar, Dr. Narsari, Dr. Tajani, and the entire team for inviting me for this lecture series. The topic is Combinatorics in Indian Knowledge Systems. Indian knowledge systems are evolved and developed over centuries in Indian culture, Indian philosophy, yoga, Ayurveda, Vedic sciences, etc. Their study also uncovers theoretical subjects like mathematics, astronomy, grammar, linguistics, and shows scientific prowess of ancient Indian mind. It is necessary to delve deep into Indian knowledge systems to understand the rationale behind these theories and harness the potential. I want to explain some contributions of some ancient Sanskrit scholars and highlight the gradual development in the topic of permutations and combinations in Indian knowledge systems in short. The purpose of this lecture is not just to showcase the achievements in the past, but to know how and why our ancestors acquired this knowledge and gained wisdom. It all started with ancient ordering techniques. Ancient Indians developed the ordering techniques and applied them in various situations. These ordering techniques are nothing but permutations and combinations in modern language. The ancients named them as Vikalpa and Bhanga. This does not mean that Vikalpa means permutations and Bhanga means combinations. No, these terms were used vaguely. It is observed that there are no separate terms for permutations and combinations. Vikalpa means alternative, option, variation, variety, and also combination. It is observed that the term Bhanga may have been used only in Jain canonical literature. In Gomatasar, written by Nemi Chandra in 10th or say 11th century, this term Bhanga is used in compounded form. Then in 9th century, Mahaviracharya composed an exclusive mathematical treatise, Ganita Sara Sangraha. And in this treatise, he did not use this term Bhanga for combinations. Language plays an important and fundamental role in original writings. In ancient India, Sanskrit was a medium of communication for imparting knowledge. Classical Sanskrit was the chief language of communication, chief language of scholars in India up to say 17th or 18th century. Now, let us see the glimpses of combinatorics in Vedic literature. First example is Pratishakyas. During Vedic times, Pratishakyas instructed to rearrange the syllables of Vedic prayers systematically, and it was considered very important in those times. Second example is ancient pharmacology. Bruhatrayi of Ayurveda used the principle of combinations to prepare various kinds of drugs from 6 different rasas. Sushruta of Sushruta Samhita fame says, Tatra etesham rasanam sanyogaha trishashtir bhavanti. And he enlisted all the 63 combinations systematically. Then in Agni Mahapuran, there is a chapter called Prastara Nirupanam. And in this chapter, the pratyayas are named. And pratyayas are combinatorial tools. Construction of Meru is also given. In short, it says, Pare Purnam Meru Prastarato Bhavet. Meru means table. It gives the total number of combinations. Next example is Manava Dharma Shastra. It is a work on religious laws and practices. Men and women of different varnas produced children, and these children were considered as mixed caste according to the restriction of the dharma. So different types of mixed caste were found. Kama Sutra. It classified men and women in different categories depending on their physical characteristics. And it gave the number of heterosexual couples as 9. So these are just few glimpses of as observed in Vedic literature, and now glimpses in Jain literature. The contribution of Jain scholars in the field of mathematics and also in the field of combinatorics is undeniable. It is necessary to acknowledge it. It is necessary to give them due credit. In Sthananga Sutra, there is a list of 10 topics of mathematics. And the 10th one, the last one, is Vikalpa. So, these Jain scholars were the first to bring this topic of Vikalpa under the banner of mathematics. There is a renowned researcher, B.B. Datta. In 1929, he wrote an article, The Jain School of Mathematics. And in this article, for the first time, he declared the existence of achievements of Jain mathematics and combinatorics. He says, B.B. Datta says, and I will quote him. He says, the early Jainas seem to have great liking for the subject of combinations and permutations, Bhanga or Vikalpa Ganita. For they are found to have employed their knowledge of that branch of mathematics in the various fields of thought. Unquote. Next example is Bhagavati Sutra. In Bhagavati Sutra, there is an application where the combinations are formed from n fundamental categories of philosophy by taking one at a time, two at a time, three at a time, and so on. And they named these combinations as Ekaka Sanyoga, Dvika Sanyoga, Trika Sanyoga, etc. Then in Gomatasar, written by Nemi Chandra, he gave the names of the pratyayas as Sankhya, Prastara, Nashta, Samuddishta, and Parivartana. Then Mahaviracharya in 9th century, who composed Ganita Sara Sangraha, he says there is much more mathematics in the Agamas. So contributions of these scholars, both Vedic as well as Jain, stimulated the growth of mathematics and combinatorics in India. There is an interesting article on Gomatasar written by Deepak Jadhav and Anupam Jain. They gave the parallel development of combinatorics in Vedic and Jain literature. Before proceeding further, it is necessary and essential to know the difference between permutations and combinations. The definitions are given in the next 2 slides. I will explain them in short. Let there be 3 letters, A, B, and C. And if I want to arrange any 2 of them at a time, then I can arrange them in 6 different ways. And these 6 arrangements are permutations, namely AB, BA, AC, CA, BC, and CB. So order of the letters written is important. Now the combinations. If I want to select any 2 from these 3 letters, I can select them in 3 different ways. And these 3 different ways are selections. These 3 selections are combinations, namely AB, AC, and BC. So although AB and BA are 2 different permutations, they are represented by the same combination AB. This is the basic difference between the 2 permutations and combinations. It is interesting to see how these principles are used in different disciplines in ancient India. Little mathematical knowledge and background will help to understand better. I will try to explain. I will start with Ayurveda. And these are the treatises I am going to refer to. Brihatraya of Ayurveda. Sushruta Samhita, Charaka Samhita, and Ashtanga Hridaya Samhita. First, let us see the combinations of rasas. Therapeutics is a branch of medicine concerned with remedial treatment of diseases. It needs the knowledge of rasas, their properties, and their effects on body. It was very important to restore the deranged three doshas, Vata, Pitta, and Kapha, to their normal state. And this can be done only with the help of proper medicinal drugs. Drugs that have the combinations of different rasas according to the condition of the patient. And Brihatraya of Ayurveda gave the exact number of combinations of 6 rasas. Sushruta enumerated all the 63 combinations by taking 1 ras at a time, 2 at a time, 3 at a time, up to 6 at a time. Charaka and Vagbhata, they did not elaborately give the combinations. They mentioned the possible combinations for each particular group of rasas. Next is combinations of doshas in Ayurveda. Sushruta first described how inflamed doshas spread through the body in various combinations. And he considered 4 doshas. 3 doshas, Vata, Pitta, and Kapha, and Rakta. And he gave a list of 15 combinations of 4 doshas as before. Charaka was a practitioner of non-surgical Ayurveda, and he tried to find the combinations of doshas, 3 doshas, with variation. He says, Vyadhinam dvi adhikaha shashtir doshamana vikalpajaha. And he took into account 3 states: aggravation, diminution, and normal state. If these 3 doshas aggravate or diminish in various degrees, or they remain steady, then according to Charaka, there will be 62 combinations of doshas. He mentioned those 62 combinations. So as compared to Sushruta, Charaka tried to move one step further. These authors first enumerated. That is, they wrote the combinations one by one, systematically, and then counted the combinations one by one. So practical knowledge was converted into methods. They needed the combinations of rasas and doshas only from the point of view of therapeutics. Accordingly, they improvised the method. Now the next discipline is perfumery. And I'm going to refer to Bruhat Samhita of Varahamir. Gandhayukti means combinations of perfumes. Varahamir discussed compositions of various kinds of perfumes. So let us first see the application of permutations in perfumery. He instructed to use 9 different substances, 9 different ingredients in increasing order of their magnitude. And Varahamir says, Kramat bhavanti dhupaha bahavaha manoharaha. He used the term bahavaha, a simple term, making it clear that this process is simple and many perfumes can be formed. He did not mention the total number of perfumes formed. He was interested only in showing the way of computing large number of perfumes. However, the concept of permutations without repetition is clearly seen underlying. And now the application of combinations in perfumery. And I will give 2 examples for this. Varahamir enlisted 16 ingredients to prepare perfumes. Out of these 16, he chose only 4. And then he mixed these 4 into the proportion of 1:2:3:4. So how many combinations are formed? In order to find the total number of combinations are formed, he used a table, Meru, and came up with the correct answer, 1820. For the construction of the Meru, he says, Purvena Purvena Gatena Yuktam Sthanam Vina Antyam Pravadanti Sankhya. So 1820 combinations are formed. But which combinations are formed? For this, he instructed to enumerate these combinations by means of Loshta Prastara in a very cryptic half verse. He introduced novel ideas. It is noteworthy that in order to adapt to the situation in perfumery, he developed innovative method to compute the combinations in Meru Prastara and then to enumerate these combinations in Loshta Prastara. Second example is that of magic square or say Sarvato Bhadra perfume. And for this he again used 16 different ingredients. As the name suggests, Sarvato Bhadra is meant for every auspicious occasion. And for this he utilized Kachaputta. Kachaputta to enumerate Sarvato Bhadra perfumes. Kachaputta is a diagram, a matrix. And Varahmir says, Shodashake Kachapute yatha तथा मिश्रिते चतुर्द्रव्ये ये अत्र अष्टादशः भागाः ते अस्मिन् गन्धादयः योगाः. Since there are 16 ingredients, the matrix is 4 by 4. There are 16 cells with 16 ingredients and only 1 to 8 digits. So each digit is repeated. Varahmir instructed to select any 4 digits such that their sum is 18. And the perfume is formed from the corresponding substances. And his Kachaputta is a magic square having fixed sum 18. Varahmir and the later mathematicians, they use Bhuta Sankhya's for wherever necessary. And it was necessary to indicate numbers by means of words. And for this, the traditionally known concepts in the culture were used. Combinatorial principles are extensively used in perfumery, but in implicit manner. Various interesting insights into the early theories of permutations and combinations can be observed in Bhuta Samhita. Next discipline is prosody. And these are the treatises dealing with combinatorics. But I am going to refer to only 3. Chandas Sutra of Pingalacharya, the earliest available Vedic and classical Sanskrit meters, Vrittaratnakar of Kedarabhatta, and Chandanushasana of Hemachandra. Of course, with their commentaries. Next slide shows 3-syllabic prastara, Triakshara prastara. There are only 2 types of syllables, Laghu and Guru, L and G. So there are only 8 groups of 3 syllables each. Each row shows permutation. First column shows indices of the permutations and the second one shows the permutations. Everyone studying Sanskrit knows this table quite well. But what will be the prastara if there are more syllables? Pingalacharya thought about this and he discovered a method to compute all possible permutations, to enumerate all possible permutations. Then he arranged them systematically and serially. And while finding such a system, he was confronted with more problems. And these problems were not even related to prosody. Nevertheless, he investigated further, and ultimately, this gave rise to the theory of pratyayas. Its foundation lies in Chandas Sutra. So, what are these pratyayas? Pratyayas are technical tools to solve the problems. Pratyaya is a process by which the particulars about the meters are known. Later prosodists like Hemachandra, Kedara Bhatta, they and few others developed this theory further and named these pratyayas as prastaro nashta samud prastaro nashta prastaro nashtamuddishtam सर्वैकादिगलक्रिया संख्या च एव अद्वयोगश्च षडेते प्रत्ययाः स्मृताः. The problems faced in different walks of life inspire a person from to explore mathematically. And in the same manner, formal system of combinatorics was developed from the theory of pratyayas. Then let us know these pratyayas one by one. First pratyaya is prastar, and it has two mathematical meanings. The method of writing a list of permutations for the given syllables, and the unique standard list of all possible permutations for the given syllables. And now, as an example, please remember the three-syllabic prastar, Rakshara prastar. Next one, the second one is nashta. When the permutation in the prastara is lost, but the index of that permutation is known, then the process of nashta finds the lost permutation. The third pratyaya is uddishta. When the index of the permutation in the prastara is lost, but that permutation is known, then the process of uddishta finds the lost index. So nashta is actually an unknown permutation of the known index in the prastara, and uddishta is the unknown index of the known permutation in the prastara. So uddishta and nashta are reversible processes. This is ranking and unranking. Next pratyaya is sankhya. Sankhya gives the total number of permutations in the prastara. For example, the sankhya of Triakshara prastara is 8 because there are 8 permutations. So this process gives the total number of permutations in the prastara for the given number of syllables without actually constructing the prastara. It's a mathematical method. Lagakriya is the next one, and it gives the total number of permutations having a specified numbers of laghus and gurus. And the last one is Advayoga. It is combinatorially unimportant. So now let us see the foundation of theory of pratyayas. The design of prastara is actually a table written on board or even in the dust on the ground. Each horizontal row shows laghus and gurus in succession. So for a particular meter, every possible combination of laghus and gurus are written. And the first row of each prastara always contains all gurus, and the last one always contains all laghus. Modern digital world and modern logic is based on the strong foundation of binary number system. Only 2 digits are important, 0 and 1. It seems as if Bhaskaracharya named them as Guru and Laghu respectively. One can say that he dealt with the matrix, showing all possible combinations of zeros and ones in n-digit binary number. At the end of Chandas Sutra, the treatise, Pingalacharya gave 16 mathematical formulae in the form of sutras. These formulae are very brief. They need explanation. Commentaries are needed very badly. Pingalacharya gave the rule for writing the Prastar, and later Prosodius tried to simplify the method. The rule is same, methods are different. Hemachandra gave two methods. First method is row-wise and is same as that of Kedar Bhatta. And the second one is column-wise, and it is same as given by Halayudha, the commentator of Chandas Sutra. Both procedures involve repetition, but there is slight difference in the procedures. The systematic construction of Prastara helped to solve two problems, Nashta and Uddishta. As I said earlier, Nashta and Uddishta are reversible processes. Mathematically speaking, the process of Uddishta converts Pingalacharya's binary number into decimal equivalent, and Nashta converts Nashta converts decimal number into Pingalacharya's binary equivalent. For Lagakriya, Pingalacharya gave a very cryptic half verse, very cryptic sutra, Pare Purnam Iti. That's all. It seems difficult to draw Meru Prastara figure from it. The commentary by Halayudha, fortunately, guides to draw it. Pingalacharya gave a rule for Sankhya in 4 sutras, and his method teaches a way to simplify the exponent. Simplification of exponent means reduction in the total number of operations. Here multiplication needed to calculate Sankhya, and it converts the higher powers into lower ones. These 3 prosodies gave different methods for calculating Sankhya. As I said earlier, the rule is same, but methods are different. Hemachandra and Kedar Bhatta, they tried to simplify all the rules given by Pingalacharya, whether they are related to prosody or not. Hemachandra commented that Ihacha prastara sankhyayoho eva upayoga nashtadayah trayah cha itra matram. So prastara and sankhya are useful in practice. Nashta, Uddishta and Lagakriya are evolved due to interest. And now, music. These are the treatises on music dealing with combinatorics. There are different ways in mathematics to describe music, to analyze music, and also to create music. From ancient times, the students and the scholars of music theory used mathematics to solve the problems they faced. Sangeet Ratnakar of Sharangadeva is the most authoritative work on Indian music. It connects the ancient and the medieval tradition of music. So it is considered as Dehli Pradeep. This is the reason why I chose the Tilam, the ancient tradition of music, and Sangeeta Ratnakar, Dehli Pradeep. It is necessary to know the foundation of Kutatanas first in order to calculate their Sankhya. What are Kutatanas? Sharandev and Dattilam, they divided music into 2 broad categories, Swara and Tal. We know the 7 swaras as Sa, Re, Ga, Ma, Pa, Dha and Ni. The ancients used to call them as Sa, Ri, Ga, Ma, Pa, Dha and Ni. And we also know the 3 registers as Mandra, Madhya and Tar. Sharandev first described the foundation on which Kutatanas are based. And step by step, he explained Nad, Shruti, Swara, Grama, Murchana, Murchana Grama. and he calculated the total number of Murchana Kramas as 392. These are required to find the Sankhya of Kutatan. And he differentiated between Shuddhatan and Kutatan. Tan is basically a Murchana. Shuddhatan is combinational, composed of only Shuddha Swaraj. And Kutatan is permutational, composed of both Shuddha as well as modified Swaraj. Both these authors, they divided Tanas into two groups, Sampurna and Asampurna. Sampurna means having all the 7 Swaraj, and Asampurna means having less than 7 Swaraj, namely Shadava, Auduva, etc. Sharangdev says, Sampurnascha Asampurnaha Vyutkrama Ucharita Swaraha Murchanaha Kutatanaha Syu. Both these authors applied the concept of permutations to compute Kutatana Sankhya. Dattila explained Swara and Tala in detail. Swara is the object to be measured and Tala is a measure. He used the concept of permutations to calculate Sampurna Kutatana Sankhya and also Asampurna Kutatana Sankhya. And he gave the method in short. He gave the final answer correctly. And he used important words like Hanyat Anantarayena. The term Hanyat indicates multiplication. It means the last digit 7, number of Swaraj, is multiplied by the remaining first 6 digits continuously. In 7th century, Bruhat Deshi referred to Dattilam and gave this procedure of multiplication elaborately, gave the answer at each step. Sharangdev tried to apply the theory of pratyas to swaras and talas in 2 separate chapters, consisting of about, say, 150 verses. Sharangdev gave the general procedure to write Swara Prastara. The rule generates tanas from 7 swaras. He explained the mathematical process of computing Sankhya of Kutatana. He gave the Purna Kutatana Sankhya of all Murchanas. And in order to find Uddishta, Nashta and Sankhya, he constructed a table, Khandameru. Khandameru is a table having cells. And in these cells, he placed the multiples of factorials of the digits 1 to 7 systematically. And then he used it to find Nashta, Uddishta and Sankhya. Sangeeta Ratnakar is one of the few treatises in which Tala Prastara is discussed. In Taladhyaya, a separate chapter, he dealt only with Chaturanga Prastara. So there are 4 elements. Druta having 1 matra, Laghu having 2 matras, Guru having 4 matras, and Pluta having 6 matras. Matter becomes difficult. Number of talas are innumerable. So he suggested a general method so that any tal can be described. And he gave a list of 19 pratyayas to understand different characteristics of tal. He increased the range of understanding of the concept of combinations by constructing 4 merus: Druta Meru, Laghu Meru, Guru Meru, and Pluta Meru. And for this, he gave importance to that particular Anga, Druta, Laghu, Guru, and Pluta. So he extended the concept of Peru originated by Pingalacharya to 4 Angas of Talas. It is observed that Sharangdev tried to apply the theory of pratyayas to music. The difference between the time of composition of Dattilam and Sangeeta Ratnakar is about, say, 1200 years. During this time, the development of combinatorics reached almost to advanced level. And now the last discipline is mathematics. Chandas Sutra is the first shastra in which the principle of permutations and combinations was used as a general computational technique. Gradually, over the centuries, it culminated into a science of combinatorics. And this is evident from these four treatises. Patiganita of Sridharacharya, Ganita Sarasangrah of Mahaviracharya, Lilavati of Bhaskaracharya, and Ganita Kaumudi of Narayan Pandit. These mathematicians used examples from various shastras like rasas in Ayurveda, arrangements of syllables in poetry, notes in music. They listed such examples along with other examples in Mishraka Vyavahara in their treatises. These Sridharacharya indicated the rule for combinations of 6 rasas, but he did not use it for any other example. But the rest of the 3, Mahaviracharya, Bhaskaracharya, and Narayan Pandit, they gave the general rule for combinations and they tried to apply it in various situations. Mahaviracharya used it to solve examples like necklace making and garland making. And in one of the examples, he asked, Vajrendra Neela Marakata Vidruma Muktafalaihi tu Rachita Malayaha Kati Bhedaha Yuti Bhedat Kathaya Sakhe Samyagashutvam. Bhaskaracharya mentioned its applications in Khandameru, in architecture for combinations of window frames, then in medicine for combinations of rasas. And he said, Musha Vahana Bhedadav Khandamerav Chashilpake Vaidyake Rasabhediye Tannoktam Vistruter Bhayat. Narayan Pandit applied the same concept of combinations to 4 different examples. New methods were evolved, and it is observed that although the rule is same, comprehensibility increased with time. Bhaskaracharya introduced a concept of permutations in relation to digits 1 to 9 and named this new topic as Ankapasha or Ganitapasha. And he gave 4 rules and 4 formulae for this in Ankapasha: permutations without repetition, permutations with repetition, permutations with unequal and unfixed digits, and the rule where the glimpses of partitioning are observed. In an interesting example, he asked to find different idols having 10 weapons in 10 hands of Panchanana Shiva and 4 weapons in 4 hands of Vishnu. Before him, the same rule for permutations without repetition was used in music by the Tila, in perfumery by Varahamihir, and maybe many others, but vaguely, implicitly. The topic of Ankapasha, introduced by Bhaskaracharya, motivated Narayan Pandit immensely. The exploration led him to knowledge and understanding, which is critical for development. Narayan Pandit developed and broadened the scope of concept of Ankapasha on the basis of the work done by the predecessors like Pingalacharya, Sharangadev. He dealt with both permutations and combinations in Ankapasha. He devoted an entire chapter to Ankapasha, having about, say, 100 verses. And at the end of the chapter, he tried to extend the concept of Ankapasha to 2-digit numbers. But he was unsuccessful. The methods of Narayan Pandit are innovative as compared to the methods of the predecessors. The concept of combinations, its application in Ayurveda and prosody, and realization of its potential for application in various situations encouraged mathematicians to formulate them and thus to establish it finally. They replaced the tool of Meru, which was used by prosodists to compute number of combinations by rule formula. It is observed that the simple idea of arranging different objects in regular order was developed, and the scope of the application was widened by the scholars of different disciplines. And then it was transformed into a rule gradually by the mathematicians over the centuries. And now, finally, the conclusion. Although these disciplines are different, one common thread is observed. They use these principles of permutations and combinations as tools to solve the problems they faced. These tools were developed slowly but gradually in ancient India. The authors of Brihatrayi of Ayurveda wrote the combinations one by one and then counted them. Pinglacharya showed a way to use pratyayas as tools for computation, which can be used for big numbers as well. This was a big step. This fascinated scholars from different disciplines. The theory of pratyayas was further developed by later prosodists, musicologists, and mathematicians. Mathematicians were greatly influenced and empowered by the new tools in prosody. They theorized the concepts. These concepts were based on the facts that were repeatedly confirmed through observation and through application. They used this as a foundation for further development. And this is noticed in the works of Bhaskaracharya, Narayan Pandit, and Sharangadev. These scholars were ready to experiment. They were ready to learn from each other. They were ready to share their findings. This give and take resulted in giving rise to the development of various innovative methods in their disciplines. Their inquisitive nature, along with the strong foundation of scientific knowledge, helped them to apply the principles of permutations and combinations in their respective works. This led to the development of combinatorics from the theory of pratyayas introduced by the prosodists like Pingalacharya. These scholars were proficient in using Sanskrit as a medium for mathematics effectively due to its flexibility as per the requirement. Alpaksharatvam at the cost of sandigdhatvam is not desirable. It is observed that the scholars of all these disciplines tried to maintain the balance of both quite successfully. In this way, a small concept of vikalpa blossomed into logical tradition and then culminated into Indian knowledge systems. It provided impetus to scholars in the intelligent circles of India, ancient India. This concept of vikalpa acted like a bij from which a tree of combinatorial study blossomed in India. Now it is important and essential to link the development in this topic in ancient India to modern development. For this, deeper research with utmost dedication, perseverance, and critical approach is needed. It is just not possible to cover details about the development of combinatorics in Indian knowledge systems in such a short time. I hope this lecture at least will give an idea about it and generate enough interest to explore this topic further. Thank you very much.